1.5 Forces Memo. Question 1. What of the list below can a force change in an object? Well, it can change the velocity, size, shape and direction, but a force may not change an object's mass. Question number 2. A car has a mass of 1,200 kilograms. The driving force on the engine is 2,500 newtons, whilst the frictional forces from air resistance are 1,800 newtons. Find the resultant force. So we're going to say 2,500 minus 1,800 is 700 newtons. Find the resultant acceleration. Well, we're going to apply F equals ma. 700 divided by the mass, 1,200, I get an acceleration of 0.58 meters per second squared. Question 3. A. State Hooke's law. The extension of a spring is proportional to the force applied, provided it has not reached the limit of proportionality. B. Define the term limit of proportionality. Well, it's the longest extension that a spring will no longer obey Hooke's law. Question 4. A spring has an original length of 12 centimeters and a spring constant of 50 newtons per meter. What will the total length of the spring be when a force of 10 newtons is applied? Well, we've got F equals kx, so x is F over k, so 10 divided by 50 is 0.2, but that's in meters, so converting to centimeters we get 20 centimeters. 12 plus 20 is 32 centimeters. Question 5. An aeroplane is turning in a horizontal circle. If the pilot wishes to turn in a smaller radius, must he increase or decrease the force on the aeroplane? Explain your answer. Well, the pilot must increase the force on the aeroplane towards the center of the circle. A greater change in motion or a greater change in velocity is required. Therefore, we're going to need a larger acceleration. If you have a larger acceleration, you need a larger resultant force. Question number 6. After riding a bicycle, the brakes feel hot. Why? Well, the frictional forces between the objects in the brakes, the brake pads and the wheel are going to transfer kinetic energy into thermal energy, and that's going to be released as heat, so your brakes are going to feel hot. Number 7. Define the moment of a force. Well, it's the product or the multiplication of a force and the perpendicular displacement from the line of action of the force to the pivot point. When an object is in equilibrium, what two conditions must be true? Well, the resultant or net force must be equal to 0, but also the resultant moment must be 0 as well. Question number 9. Describe an experiment to demonstrate that there's no resultant moment on an object in equilibrium. You may draw a labeled diagram to aid your explanation. Well, I would draw a prism in the center with a meter stick balanced in the middle and maybe a selection of masses. So the prism will be used as a balancing point. You place the meter stick on the prism so that it balances roughly at the 50 centimeter mark. Place in equal masses at equal distance from the pivot point. The moments produced by the masses should be equal and the meter stick will hopefully again balance. Number 10. What's meant by center of gravity? Well, it's a point in space where the force of gravity can be thought to act. Number 11. Describe an experiment to determine the position of the center of gravity of an irregularly shaped plane lamina, or basically a sheet. You may draw a labeled diagram to aid your explanation, and I do have a video on my YouTube channel of this experiment if you want to go look for it. So you're going to need a boss clamp, a stand, a pin and a string with a lead bob or a lead weight on the end. Basically, you're going to set up the boss, the clamp and stand, and you're going to pin the lamina. Okay, so it's free to swing at a point somewhere along the edge of the sheet. Suspend the bob from the string at the pin, and you're going to mark a line along the laminar sheet that this piece of string goes across. Then you choose a second point that's not really very close to the original point and repeat the whole process. And what you'll see is if the lamina is allowed to swing freely, okay, and then eventually rest, the second line, once you draw it on the sheet, you'll see that it intersects or meets up with the first line, and that is the point where your center of gravity can be found.